Okay, so Divcon was the second commercial diving company in the world to use helium. That was after Ocean Systems. So Divcon was started by this fellow, Murray Black. He was the stepson of a highly successful East Coast lawyer. I think his relationship with his father wasn't very good. And then he read a magazine article about the Sparling School of deep sea diving in Los Angeles. And so Murray decided to enroll in it. His father was not amused at all and cut him off without a penny. So to earn the money to go to Sparling, he got a job washing dishes on a government construction project in the Aleutian Islands in Alaska, a very remote place. Stayed there for 14 months, which is pretty good going. And so then he signed up to the school and went down and started a 4-month course. And before he finished at the school, a diver who owned a small fleet of abalone boats gave him a job. So he went and worked with this man for a while. Then he went on his own. He had enough to buy a boat and got a tender and so on. And so he was doing quite well with that. And then he took what was a rather rush jump into the oilfield diving business. And when he was working, the divers were highly paid, but he just wasn't getting enough dives. And so he knew this man, Charles Isabelle, and here is his famous observation bell. This photo was taken in about 1951. Charles Isabelle, Charlie, everyone called him, he was of a small group of very experienced divers who started well before the Second World War. Charlie Isabelle started getting work up in the Santa Barbara Channel where the oil drilling was started. Meanwhile, Murray Black, who was not a shy person, had been sort of badgering Isabelle to take him on. And well, Isabelle at the time didn't have enough work, but then he got to the point where he did have enough work. And so he said, okay, come on in and we'll work together. And so they set up a company called Associated Divers. Now, Murray Black is the person on the left in the red beanie, and these are some of the other divers. The one on the right was Gene Mogis, who was an ex-Navy diver, and he was valuable, and that was very important when it came in about forming Divcon, because he had a lot of experience in helium from the Navy. Associated fairly quickly had a virtual monopoly on diving in the Santa Barbara Channel, and that's where nearly all the work was. This was all diving on air, and it was deep work. I mean, they were diving to typically 200, 220, 225, some even deeper than that. And although most of them had a pretty good tolerance to nitrogen, and even though, you know, they were fairly sort of with it on the bottom, the thing that would happen sometimes, a diver would come up and he'd ask him, did you close that valve? And he'd say, what valve? So there was a man who was very aware of what was going on here called Dan Wilson. Dan Wilson, like most of these other people, the younger divers, and he also had been to Sparling, the diving school. And when he went there, at least, they had a short lecture on helium diving. So, you know, he was well aware of it. And so what he did was he took his Japanese abalone helmet he was wearing here, he modified it and put a second stage of a Sportsway scuba regulator. It's one of the first single hose regulators. So it breathed off the mouthpiece, and you can see the first stage under his arm. And so he got some helium from Los Angeles and some oxygen, and then rented a fishing boat and got some people he knew. None of them knew very much about diving, but he told them what to do. So they went across the Santa Barbara Channel on the other side near the islands, and he made a 400-foot bounce dive, breathing helium. On the oxygen stop, the big shark came up and he got pretty nervous. And so anyway, apart from that, everything went okay. And as he had hoped, the local newspaper, of course, reported this. And Phillips Petroleum read about it and said, well, you know, we got to, you know, try this fellow. So they contacted him and gave him what was called a work order. It's not a contract. Said, put your gear on the drilling vessel. Now, of course, he had to move pretty fast because he had to get some more people to help him. And he got these two people, Laird Handelman on the left, of course, who went on later and founded one of the founders, Oceaneering, and the right, Whitey Steffens. Actually, Whitey Steffens eventually became the area manager for ocean systems on the West Coast. Fairly shortly after they got the first job, Phillips called them out to get the vessel off the hull. Phillips was having trouble, and I'll tell you why later. It's because they borrowed from Shell a thing called the Mobot, which was a robotic system which never worked. That went okay. First job was good. And so then they really went at it. I mean, in a fairly short time, they had 60% of all the work in Santa Barbara Channel. And so helium was the thing, and Associated Divers did not have helium, and they didn't disappear, but they certainly no longer had the monopoly they had before. So here you can see General Offshore was the name the company started. Here's one of the divers working in, jumping in. The fellow in the check shirt, that's Laird Handelman there. Now, okay, so Murray Black had by then left Associated Divers, and by 1963, he had started Divcon and was going into helium. The fellow I mentioned before, the ex-Navy fellow, came to work for him, and he's in the front row on the left, G. Mogus. Murray is on the right. He's got his hand on the fellow who put up the money, who was Barney Clancy. Clancy had the biggest fleet of abalone boats on the coast. Black went to him as the money man. So that's how they started out. You can see this bottle of gas, and then in the background, the Manifold and so on. And so this was the original group. There's one fellow that's missing from the photo, but that's basically it. Because of Mogus, they stuck very closely to the US Navy procedures. So what they did, they got standard helmets and modified them and put here a canister on the back, which was where the scrubber was. But the one problem was that the US Navy's used as for scrubbing agent some stuff called Shell natron, and it was highly caustic, and they didn't want to use it. Murray was very worried about this, and for good reason. So fortunately, he went to the local hospital to get his sinuses purged, and he noticed there was a patient on a closed circuit respirator, and he asked the technician, he said, how do you purge the CO2? And the fellow said, with a disposable cartridge of stuff called soda salt. So he told the engineer who was helping them to build a canister which would hold 2 of these soda salt cartridges. Of these helmets, they built 2, and later on they built another 2. And by that time, they had found out that you really didn't need 2 cartridges, one on top of the other. So the second 2 helmets, the canister, of course, is much shorter. Both the older ones and new ones had a screw cap in the bottom so you could take the cartridge or cartridges out. And they used the same specifications as the US Navy for the Venturi. And then, like the Navy, they used what they call a belly valve. So in other words, the intake valve was not on the helmet, was really around the diver's belly that was on the hose. That's why they called it belly valve. Here's Divcon's base in Santa Barbara with their trucks, and you can see the Manifold, which is a monstrous great thing. And they used high volume tanks, which are high pressure butane tanks, and they used the same, I think it's called a Grove, made the regulator. So I think it's almost certainly one the Navy used. But anyway, the whole thing was big enough to where it would run a complete diving system on a Navy submarine rescue vessel. So it was overly bulky for what they were doing anyway. So they also followed the Navy on the procedure, which meant they used the mixed gas throughout. So that meant you had to have a mix of no less than 16% oxygen, so that prevent the diver from passing out on deck. And then, of course, because they were using helium throughout the dive, there were long, cold decompressions on helium, and then 50 and 40-foot water stops on oxygen. Now, in 1963, Divcon got a contract with Shell on this vessel, the Glomar II. Now, this lease was off Point Reyes, and Point Reyes sticks out. It's north of San Francisco. Weather up there can be pretty bad, rough seas and so on. So this lease was at over 300 feet, which was the deepest offshore oil lease anywhere in the world at the time. And so because of this, Murray Black enlisted Captain Albert Benke of the US Navy, and is, a very famous name, did a lot of research work and so on. He got a hold of him on an informal and unpaid basis as an advisor to modify the Navy helium tables for working up there. On this job, they made the first working dives to 338 feet, followed later by what were the first working dives to 370 feet. And the divers were paid as much as $1,200 per dive. Now, today that is worth approximately $10,700. So pretty good pay. One of the problems up there was there was a lot of standby time. And so that increased the bills that Divcon was submitting to Shell. And it wasn't just the weather, the standby, and all the rest of it. It was this system, the MOBOT, that was down there. Well, the MOBOT, which I said was designed and built by Shell, and the idea was, it's going to get rid of divers and all the rest of it. Well, it turned out it was absolute cash cow for divers because it went wrong so much. They're constantly having to go down and rescue the thing. So Barney Clancy was submitting bills to Shell of $112,000 for 7 to 10 days, basically just sitting there. So at some point, the superintendent came down and said, "We're getting you bunch off this vessel." The bills would have been even higher had Divcon not borrowed or rented Charlie Isabelle's observation chamber, and you can see it here on the wharf in Santa Barbara. So obviously that reduced the number of dives. So, just the guy would just get in the observation bell, go down, and that was fine. That job was a big success, despite huge complaints from Shell about what it had cost them. So then the next thing that came up was Murray got a call saying that the Glomar 5, which was a sister vessel of the Glomar 2, they were drilling off Libya in the Gulf of Sirte, and the vessel had been shut down for 23 days, and the rate of operating cost was $30,000 a day. And they said there was no prospect of the British diving company on there of getting it back on, getting it up and running again. And this wasn't because they weren't good divers, because they were, but they were just horribly badly equipped, and they were working at down to 250 feet with just face mask and a second stage regulator on the end of the hose, and they were communicating with rope pulls and decompressing in the water hanging on the guide wires, and they even had to temporarily disable the relief valve on the compressor to get, down to where they had to work. So they, of course, had to leave the rig, and naturally Divcon replaced Underseas, and Underseas was named the British Diving Company. And so Divcon was given a contract to 410 feet where the US Navy tables stopped. And Black thought actually they would not actually be going deeper than 350 feet. So anyway, he shipped all their equipment over to Libya and brought over most of the divers from Santa Barbara. And Libyan Atlantic, not too long after being on the vessel, came around and said, we're moving to 525 feet. But can you go that deep? So all Murray could say is, well, we'll try. So either through Captain Benke or through the brother of one of the tenders who was computer programmer in Las Vegas, they got the US Navy helium tables extrapolated from 410 feet down to 525 feet. This is the Glomar. So on the first dive, before going down, they lowered the bell to 500 feet and put an alarm clock in the bottom. They set the alarm clock for 15 minutes. And so the idea was, okay, if you'll hear it over the telephone, the alarm clock going off, that means all's well. If we don't hear it, it means that the alarm clock drowned, and it's not okay because, the bottom of the bell is flooded. So anyway, the alarm clock went off. Murray climbs in the bell and is lowered down to 500 feet to guide the marine riser into place. So he guides it into place, and then there's a series of bangs, and the marine riser, the pipe, goes over sideways and just misses the bell with black inside it, of course. And then all the strain was thrown on the bottom. There's a sort of bolts breaking around the flange. And so, in other words, the whole riser's on the bottom in 525 feet of water in pieces. So Murray Black said they're going to have to get all this stuff off the bottom. So it was going to take 8 dives because it was in 8 pieces. Black did the first dive. Now, you can see here, it's one of the first 2 of the helium helmets they made, because you can see the length of the canister. This chap he's sitting with is a fellow called Clive Banks, who was the supervisor for Libyan Atlantic. Murray had a serious financial problem this time. What happened was that when the contract came up in Libya, his partner, Barney Clancy, he didn't want to move over there. So Murray Black had to buy him out. Now they're on the ship, and he's got to pay his divers, and he didn't have the money to pay them. So he said to Clive Banks, "Can you lend me $10,000?" And so Banks said to him, "I'm going to lend you the $10,000, but at the end of the year, I want it back with another $10,000 on top." So Murray said, okay. What was he going to do? Murray made the first dive. It was down to 468 feet. By this time, they were no longer using the Navy procedure, and instead of going from the surface on helium, they went down on the stage to 30 feet on air and then switched to helium. So what they did was, when the manifold operator would switch them over to helium, the diver would start counting 1 to 10. And then when he heard his voice pitch change, he knew he had the helium, and then he'd leave the stage. This photo of the diver, obviously in the Divcon helmet, I don't think it was taken in Libya, quite honestly. I think it's probably taken here. But anyway, it gives you an idea of what it looked like with it on the diver. So dive 2 was to 525 feet at night. And this was Walt Thompson who made that dive. So he went down to 30 feet, switched to the gas, and he went from 30 feet to 525 feet in 5 minutes. So he just dropped absolutely like a stone. He got to the bottom fine, and so he started slinging section of riser down there. But it was hard work, so he sat down on the pipe for a little bit and then went back to work. And 28 minutes after he left the stage, he started his ascent. So the first stop was at 420 feet, and at 2:40 a.m. on schedule, he arrived at 50 feet and switched to oxygen. So 13 minutes after switching to oxygen, he said he reported that he was dizzy, nauseated, and the guide wires were twisting in front of him. So Mogis put him back on helium, then brought him up to 40 feet, but he didn't feel any better. So Mogis decided to treat this as a central nervous system bend. And he lowered him back to 100 feet where he got immediate relief. And then he dropped him down a further 10 feet, and then the decompression started again. So finally, at 4:21 in the morning, cold and debilitated, he arrived at 40 feet and breathed oxygen for 32 minutes, was brought on deck, put in the chamber with Black in there. And as a precaution, Mogis recompressed him to 110 feet and then brought him up in stages to 50 feet, trial stages. And Thompson was vomiting in a bucket while Black was consulting the US Navy diving manual. But anyway, at 9:38 in the morning, that's nearly 13 hours after the start of the dive, he emerged from the chamber. So he's obviously weak and tired, but he's otherwise all right. So the question there was, he probably had a CO2 buildup on the bottom. And the other was that Divcon was using a 90-10 mix, 90% helium, 10% oxygen. The trouble was that it was good for 350 feet, which is what Black had expected, the maximum, but it was too rich for 525 feet. So the next dive was made by a fellow called Gene Gallagher, who was in that original group in Santa Barbara, and he went to 468 feet. It was a 5-minute dive. Reason I mention this is that that's how things were in those days. At the time when he made that dive, his total diving experience was 7 200-foot air dives and 1 helium dive. So then dive 4 was Murray Black, that's back down to 525 feet. He was only down there for 14 minutes. So on this dive, he had 5.5 hours of water decompression and 2.5 hours in the chamber. The diving log noted that unlike the preceding dives, Black had been switched from helium to air at 120 feet. And on dive 5, the switch was made at 150 feet, and thereafter they switched at 170 feet. So they were changing things as they went along. So now we're in the North Sea. In December of 1965, Murray Black got a contract on Mr. Cap, which is this jackup rig. And he sent a fellow called his ex-Navy diver called John Dowds over from Libya to make this dive on this jackup rig, Mr. Cap. And that was, from what I understand, the first oil rig dive in the North Sea, off a rig. After that, they got a second contract in the North Sea on the Glomar 4. And at that time, they could see that the North Sea was going to become a pretty big place to work. So Divcon moved their headquarters to London. So I put this picture in. It was called the North Sea Bubble. I mean, this was a gas blowout, and the rig's the Constellation. This was actually taken in 1968. It was taken by a fellow called Bernie Stockton, and he was another guy like Dowds that had been in that original group with Underseas Limited. It's quite a dramatic picture. So then most of the drilling in the North Sea then was in less than 120 feet. So it's all mostly in the southern North Sea. But Black realized that to keep pace, Divcon was going to have the ability to work beyond the practical range of surface diving. And that meant two things. One was on the physiological side, improving the helium oxygen decompression tables, and on the engineering side, to build lockout diving bells. On the physiological side, Murray Black managed to get free use of the RNPL Deep Trials Unit, the Royal Naval Physiological Lab, to test Benke's tables, which went down to 600 feet. Testing began at 250 feet and then progressed in 50-foot increments with different mixtures and schedules. And Black and John Dowds made the first dive on each table. And that's a photo of the RMPL, the chambers there at that time. One of the dives, which was really a tough one, was the first 400 feet for 1 hour on the bottom. These were all fast compression dives. And so when they got to the bottom pressure, they had 2 manual dexterity tests they did. And as Murray Black said, he said our scores were very, very low. And probably what was happening was, they had hand tremor from very rapid compression. And no one knew about high pressure nervous syndrome in those days. Having done their tests, they were brought up to the first decompression stop, which was at 200 feet. And at about 120 feet, Dowd said he had a tingle in his wrist and then in his knee, and then a severe knee pain. So they were recompressed. So it was a very long therapeutic decompression in cramped conditions. But one of the problems with the test series was that as they were bringing divers in from the field as subjects, they tended to sometimes not report when they had a bend. And the reason probably for that was that, they thought, it would be a bad mark against them and they wouldn't get work. That, of course, meant that those divers were invalidated. The trials, in fact, stopped at 400 feet, not 300 feet. And what Dowds had told me when I interviewed him, he said that Divcon kept running into difficulties during and after decompression. These tests was the basis for the Divcon tables, and they were used for many years, but they were well known as being far from perfect. Moving on from that is the engineering side with the bells. So they started designing and building the first bell, which was called the SeaTask. This bell was designed to go to 600 feet. It was a monster, weighed 11 tons, fully equipped with a crew of 3, and had a 2.5-ton clump weight and emergency gas and cylinders round the bottom and a life support for 36 hours. Of course, the selling point, obviously, of these lockout bells was the big reduction in rig downtime, because they didn't have to shut the rig down while they were waiting for a diver to decompress in the water. Here's a photo of it. In 1966, Divcon got a contract for SeaTask 1, the first one, on the Glomar North Sea, which was a vessel in the Persian Gulf, depth about 300 feet. So you can see here this installation drawing. And one of the problems here was that apparently Murray Black or someone in Divcon had told Global Marine that they'd sort of implied that it was a nice little package. You can just stick it in the corner. You won't even notice the thing. And in fact, the entire thing, it needed its own davit and 600 to 700 square feet. So obviously it did take up a lot more space than had been advertised. So anyway, while the SeaTask bells were being built, and they built 6 of them in all, Murray Black bought the Italian Galliati chamber, to lockout bell version. And it was shipped over to the Glomar 5 in Libya, and they put it in the water. So they discovered to their horror that even without weights and no one on board, the thing wouldn't float. So they added a flotation collar, but there were apparently 2 incidents where the load line broke, and there was one in Western Australia. The bell was sitting on the bottom and no way to get out of it. So what they did is one of them divers would go climb the top of the bell and rock the thing back and forth. And then these drop weights would drop and, the bell came up, but it was a, fairly hairy kind of situation. Or this one of the later Divcon, their Galliati Bells. And here's another one on deck. The divers were diving to 400 feet with these bells, and you can imagine they were using standard dress gear, so it was really tight fitting now. What happened after a while, not surprising, is that the standby diver wasn't wearing standard dress. He'd just go down with a face mask and a hose and a regulator. This, you see some pictures of the upper SeaTask, and this is the chamber and the lower chamber. Then the Divcon switched to these, which were helmets built originally and designed by Bob Kirby, and that what became Kirby Morgan. These became eventually standard helium helmets. Working out of the SeaTask in heavy gear really wasn't practical, so they switched to this Draper semi-closed system. They weren't very popular with the divers because it was sort of almost had to exert themselves to breathe out. They would get out of breath and they'd have to go back into the bell to get their breath, or they'd breathe the emergency gas in the backpack. And this is Walt Thompson in the Persian Gulf with one of those units. Later, they switched to a new design of bell, which was called the Seashore, which was just a single compartment bell. It looked like the SeaTask because it was self-contained, the gas bottles all around the bottom. So the silhouette looked the same, but it wasn't the same. And those bells were much more successful and much more practical. And in fact, they were practical to the point that when eventually Oceaneering bought Divcon, they used the Seashore bells quite a bit. Divcon got into financial troubles, and they actually had been bought by a conglomerate, and the conglomerate wanted to sell them, and so Oceaneering bought Divcon. So in a nutshell, that's what it's all about. That's the story.